Hi, my name is Avinash. I work for Celestica. My co-presenters Damo and Naveen couldn't make it, so I'll try and cover for them. Okay. The context for today's presentation would be a rack management application that is leveraged from OpenRMC DM. At a high level, the problem statement, this is kind of a segue into the previous talk. Think of a fleet of racks for AI compute, with each rack comprised of a bunch of disparate rack elements, compute nodes, network elements, storage elements, power shelves, CDUs. And each of these elements would have a BMC endpoint, a BMC IP. Some of these elements, like the network elements, would additionally include an out-of-band management interface. So how do I manage such a fleet of racks to facilitate correlation of events, to be able to do context-aware telemetry and stuff? And that is the overarching problem statement. Like right now, you do have a piecemeal solutions, like you do have solutions that do network orchestration for orchestrating your network fabrics. Server vendors do provide you a way to manage the servers piecemeal. But if you need to correlate all these together, and where an event in one entity would require you to react in another entity, it makes it a little hard. Or you will need to write another layer of software that ties these things together. So one other way to solve it is to build a unified rack management and monitoring solution with a prescriptive transport. Why prescriptive transport? Whatever you build, you might, like if I build a bunch of hardware, I would want to have a standard way of exposing management to a management application. If I'm writing a management application, I should be able to talk to multiple vendors using the same language. In that context, we are deriving from what OCP prescribes, which is like Redfish as a standard transport for BMC endpoints for all rack elements, and GNMI as a standard transport for management of network elements. But the focus of this talk specifically would be on the Redfish-based conversations to the BMC endpoints and how we can leverage OpenRMC DM to build this part of the unified rack management monitoring solution. This is just a visual representation of what I was just talking about. In this figure, it's like the left side represents a GPU cluster with 2 racks. And for the purpose of this discussion, think of the unified rack management monitoring solution as an external application sitting on a server form factor device with IP connectivity to each of the rack elements management network. That is the context. And you imagine a bunch of these GPU clusters together and a centralized unified manager, monitor, controlling all these. That's the general idea. Now, bringing in, where does OpenRMC DM fit into all this? I'll start with the current capabilities of what OpenRMC DM offers. OpenRMC DM, essentially, it provides a common abstraction layer for a multitude of BMC endpoints. On paper, it is a rack manager in the sense that it was thought of as an entity that would, behind it would be every BMC element within a single rack. That is its context. And what it does is it discovers, first is you can onboard a bunch of BMC elements onto the OpenRMC DM. And for each BMC, what it does is it discovers the entities behind the BMC endpoints like system, chassis, and the sub-resources behind them, and it caches all of them in Redfish database. It provides real-time access to this data for telemetry. Like if you want to do gets on all those ERIs, it provides you a way to do that. It also provides a way for you to operate on do operations on subset of resources. By operations, I mean stuff like firmware updates or resets, like actionable entities. And one additional thing which is kind of very useful that OpenRMC DM offers you is a way to aggregate these BMC endpoints together. You can aggregate a bunch of these together, create an aggregate, and perform operations on top of these aggregates. Today, it doesn't really limit what you can aggregate, and it doesn't even really limit it to a rack boundary. For all you know, you could say aggregate front-end switches of n different racks and perform group operations on them. In a practical sense, right? If I want to do an upgrade on one top of the rack BMC, I would typically, it's probably a vulnerability I've seen, it would be applicable to a bunch of, like every BMC of every TOR. So it provides you a way to group those operations, which is very nifty. So that's only thing is today it is limited to this aggregate capability is limited to system endpoints and operations on them. So it's limited to upgrades and resets. You can't do like stuff like get or any other operation is not, today it's not supported. Now, I'll get to how OpenRMC DM can be leveraged to multi-rack management. One thing is like OpenRMC DM today does not stipulate a boundary to the set of BMC endpoints it is governing. Although it is imagined as a way to govern BMC endpoints within a rack, it doesn't really implement this constraint. So you can potentially, it depends on how much juice the processor where you run OpenRMC DM has. You could group as many BMC endpoints as you want. So in essence, what I'm saying is a single OpenRMC DM can manage BMC endpoints across a multitude of racks, as long as you have a higher order application to manage the mappings of who sits where. So which means I would need a higher order application. For the purpose of this discussion, let's just call it device monitor. This needs to run as part of the unified rack management solution. It needs to have a notion of racks, and within the racks, what nodes it has. A node is either a compute element or a network element or a CDU or anything. And within each node, it needs to have a notion of BMC IPs. Now, what the device monitor would do is, it would instantiate the BMC endpoints within each of these nodes at the device monitor. When a BMC endpoint is instantiated at the device monitor, what the device monitor does is it creates a UUID to identify that specific BMC endpoint instance, and it prepends that UUID to every resource that will need to be passed on to the device monitor. Essentially, that's what a BMC would do, right? BMC would, it's like a discovery process. You will get the entire URI tree and get passed on to, if I'm directly running on top of a BMC, I would get the entire resource tree. If I'm running off a device manager, for each BMC endpoint, I would get the resource tree, and I would prepend the UUID that I have for that BMC endpoint, and I would present that to the device monitor. And at this point, like the device monitor, it would access each of those endpoints in this form. The numeral in the middle, that represents the UUID. And so the way a device monitor would hit the various endpoints is like /redfish /v1/chassis/uuid dot whatever board it is, whatever the endpoint it is. Now, what the device manager does when it initially onboards a BMC endpoint is that it will create, when it creates a UUID, it creates a mapping between the actual IP of the BMC endpoint and the UUID itself. And when those endpoints get hit from a higher order application, it strips off the UUID and it knows the IP address. Now it's like I'm a regular Redfish client sending a URI that the Redfish server would understand to an IP that I get by mapping the UUID to the corresponding IP that I remember. So device manager remembers these mappings, and that's how it achieves it. One other thing is like the higher order application, right? When I said it needs to have a notion of rack, node, and stuff, that is the user context of each entity. And that application has a user context mapped to the UUIDs, and that's how it would talk to the device monitor. Device monitor would frame the URIs with the UUID prepended. The URIs would have the UUID prepended. That would hit the device manager. Device manager would strip the UUID, and now it has a regular looking URI. It has a mapping to the IP, and now it can talk to the actual Redfish server running on the BMC. This table just represents what I was describing. Device monitor does not have a notion of URI. It invokes the device monitor with the UUID prepended URI. At the device manager, I would receive the UUID prepended URI. I would strip the UUID and route it to the actual device BMC. And now the actual device BMC would process this request, respond back. And the reverse mapping happens all the way so that the origin receives what it needs. This is a visual representation of a single instance OpenRMC DM, where to the left is the unified rack manager monitor. And then there is a device manager, which is like, we have picked up the open source application, and that's what we're using for this implementation. And which the device monitor talks Redfish to, device monitor talks Redfish to OpenRMC DM. Essentially what OpenRMC DM does is it acts as a Redfish client to the bunch of BMC endpoints, and it acts as a Redfish server to entities to the north of it. Essentially bridging a many-to-one mapping, as opposed to an application having to talk to multitudes of, like maintaining multitudes of Redfish connections. It has a way to abstract it through one entity. That's what it does. In this figure, if you see, the unified rack manager to the device monitor is a REST. Like as of now, it is REST, but like while going through it, we are considering keeping that as Redfish as well, because we see value in it, in which case the device monitor itself could be a openly publishable consumable entity that can be leveraged by any vendor. That's something we are thinking about. Now, to some of the challenges that are there today in terms of what I just spoke about, while a single instance OpenRMC DM would work for a smaller scale, I mean, maybe sub 10 or 10s, it may not work well for higher order rack scale deployments. One way to circumvent it is to do multiple instances of OpenRMC DM, essentially split the problem. But OpenRMC DM is kind of slightly heavyweight. It has a Kafka message service. It has a lot of infrastructure stuff, and it kind of does not make sense to replicate it. So if we find a way to peel out those infrastructure pieces, make a lightweight OpenRMC DM, and distribute the load, maybe run one instance per rack, which is how the original solution was imagined, or group a bunch of racks together to be managed by one OpenRMC DM and have a common infrastructure layer. That's one way to do it. Another potentially more standard way to do it is to build some kind of standard aggregation model, which like in the last conversation was referring to that at some level. So in that context as well, that's like a very active topic of discussion in the forum, in the OCP calls today, in the monthly calls. So one way to do it is have a hierarchy of device managers itself, or there could be other ways. So that's another direction and an active problem that is being solved right now. This is a visual representation of a multi-instance OpenRMC DM where we have, this shows one instance of OpenRMC DM per rack. But again, this would require us to peel out, and otherwise this is going to be a slightly heavyweight to be able to be viable. Right now, I'll talk about some of the extensions that have been done to the base OpenRMC DM to make it viable and consumable in a real environment. One is a Redfish event listener to the device manager plugin, wherein the base device manager did not have a way to subscribe to events that are publishable by the BMC and ship it back. So that has been implemented where when I onboard a BMC endpoint, right now it is a star dot, so we subscribe to every event. There's no fine-grained support yet. But we did introduce that infrastructure to subscribe to a bunch of, to all the events and then have a way to ship it back to the application. The second is base OpenRMC DM supports only a simple upgrade, which is like a pull upgrade. We've introduced push URI as well as a multi-part push URI, wherein for upgrades, you can send the image to be upgraded inline as part of your call to make the upgrade. And what multi-part push URI allows you to do is it also, in the same endpoint, it allows you to tell who you want to upgrade, like a BIOS or who, and what action, like immediate or on the next reset. So that support has been added. Besides that, we've introduced mechanisms to track asynchronous device operations. For instance, from a device monitor, from a higher order application, I've triggered an upgrade. That's an asynchronous task at BMC. How would I know whether that is complete or not? That was another missing piece which has been implemented. One other thing that's not here, but that's been done is today, OpenRMC DM has a constraint of the presence of a system entity for any endpoint to be onboarded. But for things like CDUs, right, typically there won't be a CPU or a host. So that particular limitation had to be overcome to allow us to onboard entities that do not really have a system endpoint. We plan to contribute this back to the OpenRMC DM repo. Call to action, join the OpenRMC DM subproject. We would champion adoption of OpenRMC for orchestration solutions within your organizations if you're building one, and get involved in building potential application extensions. Like a couple of things where we're thinking of actively extending is, one is, are there any other areas where beyond upgrades and resets where aggregate operations make more sense. That's one area. Another area is the actual act of peeling out the infrastructure layer and making a thin form factor OpenRMC DM available for consumption. These are the two implementation side active things. Discussion side active thing is the aggregation models. That's what is the prime live discussion happening in the monthly calls. That brings us to the end of my talk. Thanks for your time.
We've got about 45 seconds for questions if somebody's got one real short one.
All right, so short question. Well, actually two questions. What is the language in which you implemented the DM? Programming language?
The device monitor or device manager?
The device manager.
Python.
Python. And then the mapping between your UIDs and IPs, is that in a database of some sort? Or?
It's in a Redfish DB.
Okay, and where do you get the credentials from? Like when you have to talk BMC, when device manager has to talk to BMC?
In our current, see, our focus is like to qualify our rack build-outs for our customers. So right now we hard-code it, it's open. I mean, the security side there is work.
Okay.
But right now we get it working so that we manage to test our rack build-outs, yeah.
Okay, all right.
Thank you very much. Appreciate it.
Thank you.